Welcome back to Database Internals Crashcasts. I'm Sheila, and as always, I'm joined by the database wizard himself, Victor. Before we dive in, I just want to remind our awesome listeners to rate our podcast on whatever platform you're tuning in from. Your feedback means the world to us.
Thanks, Sheila. And hello, everyone. We're continuing our journey through database models, and today we're exploring the network model. It's an exciting topic that bridges the gap between the hierarchical model we discussed last time and the more modern approaches we'll cover later.
Absolutely, Victor. But before we get into the nitty-gritty, I've got a brain teaser for our listeners. Here's the quiz question of the day. Which major airline reservation system, developed in the 1960s, was one of the most significant implementations of the network model database? Think about it, and we'll reveal the answer at the end of the episode.
Ooh, that's a great question, Sheila. It really highlights the practical applications of the network model in its heyday. I'm sure many of our listeners might be scratching their heads, wondering how airline reservations relate to database models. It's fascinating how these seemingly abstract concepts have such concrete, real-world impacts.
Exactly. Now, before we dive deeper, let's define some key terms. Victor, could you give us a quick rundown of what we mean by network model in the context of databases?
Certainly, Sheila. The network model is a database model conceived as an improvement over the hierarchical model. It organizes data using two fundamental concepts: record types, which are similar to tables in modern databases, and set types, which represent relationships between these records. Unlike the hierarchical model, the network model allows for many-to-many relationships, giving it more flexibility in representing complex data structures.
That's really interesting, Victor. So, if I understand correctly, the network model is like a more flexible version of the hierarchical model we discussed in our last episode. Could you explain how it differs from the hierarchical model?
You're on the right track, Sheila. The key difference lies in the relationships between data. In the hierarchical model, data is organized in a tree-like structure with a single parent for each record. The network model, however, allows a record to have multiple parent records. This means it can represent more complex relationships, like many-to-many, which are common in real-world scenarios.
I see. So, it's like the difference between a family tree and a social network, right? In a family tree, each person has only one set of parents, but in a social network, people can have multiple connections to others.
That's an excellent analogy, Sheila. It perfectly captures the essence of the network model. Now, let's talk about some of the advantages this model brought to the table. The ability to represent complex relationships made it much more suitable for certain types of applications. For instance, it was particularly useful in manufacturing and inventory systems, where parts could belong to multiple assemblies.
That makes sense. But I'm curious, Victor. If the network model was so flexible, why isn't it more prevalent today? Are there any disadvantages or challenges associated with it?
Great question, Sheila. While the network model was indeed more flexible than its predecessor, it came with its own set of challenges. One major issue was the complexity of implementation. The intricate web of relationships could become difficult to manage as databases grew larger. Additionally, querying data often required knowledge of the database structure, making it less user-friendly than newer models we'll discuss later in the series.
I can see how that could be problematic. It sounds like you'd need to be a database expert just to use one effectively. Are there any modern systems that still use the network model, or has it been completely phased out?
While it's true that the network model isn't widely used in new systems today, it's not entirely extinct. Some legacy systems, particularly in industries like manufacturing or aviation, might still use network model databases. However, most organizations have transitioned to more modern database models, primarily the relational model, which we'll cover in a future episode.
Fascinating. It's amazing to see how database technology has evolved. Oh, and speaking of evolution, I remember reading something about codicil. Wasn't that related to the network model somehow?
Absolutely, Sheila. You've just brought up an interesting piece of database history. CODASIL, which stands for Conference on Data Systems Languages, was a consortium formed in 1959 that played a crucial role in the development of the network model. They published the specifications for the network model in 1969, which became a standard for database management systems of that era.
Wow, I didn't realize the network model had such a formal backing. It really emphasizes how important it was in its time. Now, Victor, for our listeners who might be struggling to visualize how data is structured in a network model, could you give us a simple example?
Of course, Sheila. Let's use a library system as an example. In a network model database for a library, you might have record types for books, authors, and publishers. Now, a book can have multiple authors, and an author can write multiple books. Similarly, a publisher can publish many books, and a book might be published by multiple publishers in different regions. The network model allows us to represent all these many-to-many relationships efficiently.
That's a great example, Victor. It really helps to see how the network model could handle complex real-world scenarios. Now, as we're wrapping up, I think it's time to reveal the answer to our quiz question. The major airline reservation system developed in the 1960s that was one of the most significant implementations of the network model database was, drumroll please, SABRE, or Semi-Automated Business Research Environment, developed for American Airlines.
Excellent, Sheila. SABRE was indeed a groundbreaking system that showcased the power of the network model in handling complex real-time data processing for airline reservations. It's a perfect example of how database models directly impact our everyday lives, even if we don't realize it.
Absolutely, Victor. To summarize today's episode, we've learned that the network model was an improvement over the hierarchical model, allowing for many-to-many relationships. It was more flexible but also more complex to implement and query. While it's not commonly used in new systems today, it played a crucial role in the evolution of database technology and paved the way for more advanced models.
That's a great summary, Sheila. And remember, folks, understanding these historical models helps us appreciate the strengths and limitations of our current database systems. It's all part of the fascinating journey of database evolution.
Couldn't agree more, Victor. And with that, we wrap up another episode of Database Internals Crashcasts. We hope you've enjoyed our deep dive into the network model. Don't forget to visit crashcasts.com, join our Discord community, and if you're feeling generous, support us on Patreon. Your engagement keeps us going. Until next time, keep your queries optimized and your data normalized.